Assalamu alaikum. Introducing myself, I'm Dr. Ghulam Mustafa Bro, and I'm a postdoc in Interdisciplinary Research Center for Aviation and Space Exploration at King Fahd University of Petroleum and Minerals, Saudi Arabia. The topic that I'm going to present today is paper ID 32, and its title is Integrating UAV Acquired Data Augmentation and Deep Learning for Solar Panel Defect Detection. So, this is the topic, and if we move forward, the contents of these presentations are in a traditional way presented in front of you. First, we cover the related background. After that, we cover problem statement. And then we propose our methodology along with results and discussions. Lastly, but not least, is conclusion followed by references. So, the related background is quite clear that there are several countries they actually go for big projects of solar panels. And the solar panel, why not? They are adopted, um, you know, globally in several countries. But the thing is, with the adoption, UAV can play a very vital role while analyzing which PV module or which PV plate is out of order. Apart from that, this is kind of a very convenient way for mega projects where you can find thousands of the beds, thousands of PV beds are there, and of course, like if you go manually and check the defects or analyze the temperature manually, it will take a lot of time. So in this regard, we come up with the background that UAV captured images and then later on applying AI and machine learning over it to visualize the data and predict the maintenance. It will make our life very easy. And this will not only improve the solar system, its efficiency, but it will give a longevity for our panels. And then also we can contribute to our climate sustainable development goals. Apart from this, solar panel capacity is projected to grow significantly, which we have observed. It can go up from like around 900 gigawatt in 2021, and now right now it's 3,206. Will be 3,206 by 2030. So this shows that how much there is a need for us to focus on the maintenance and predictive maintenance for these kinds of solar projects. Ladies and gentlemen, these are the state of the art approaches that have been deployed on PV modules in order to identify that what sort of defects it is. And you can see that several papers they produce several efficiency output. Our aim was to come up with a technique which is like hybridized, utilize the data properly and compute the output in a very efficient way. You can see few of the techniques like the maximum efficiency that we got from the literature review is the eddy current thermography, which is like we call it ACT system based on principal component analysis. So this is the 97.90 until now the algorithm that provides really good results. So problem was very clear that these techniques that actually provide the results with several efficiencies, like someone is providing 95, someone is providing 97, but then it is limited to certain data set and certain sort of problems. There are several other problems which were not accommodated in these techniques. Like few techniques consider only the cracks, identifying the cracks. Few people considered only monitoring the thermal or temperature readings. Someone computed any dust on the solar. So these were like different kind of things that have been addressed so far. Now the thing is, we want to have kind of a universal solution that proposed the solution. So before moving to solution, let me just briefly define what is the problem. Like the rapid expansion and rapid falls and several faults actually enable us or make us, put us in a condition that we have to come up with a technique that can address all of these issues. And of course, AI is one of the tools that we can deploy. So what is our methodology? We actually took the images of clean panel and the defected panels and then pre-process them so that we can get the data properly and clean data from where we can apply the our algorithm. So we are applying efficient net B naught as which we actually train our data, and then after that these data is once trained, we get the better results. Like we have gone through, we fly the drone to capture these images. The drone that have been used was UAV DJI Mavic Air 2. Almost 885 solar panel clean and faulty images were trained, and this is our methodology that we propose for our conference, this research conference paper. So you can see one more thing that in training 633 images, we have validated 133 images and tested 132 images to support our model and development and evaluation. Data set were like divided into clean, dusty, bird drop, and electrical damage, physical damage, and snow cover data sets. Moreover, these are the results, ladies and gentlemen. You can see that the accuracy for our algorithm is 92%, along with precision, recall, and F1 score. You can see for different problems, like different classes, we specify different F1 score, precision, and recall. The results are really good. And this one, bottom one, you can see the confusion matrix. Over here, it identifies the thing with accuracy as well. This is the graph that actually shows that the graph in between training and validation accuracy and validation loss. So conclusion is like with the expansion of solar panels all around the globe, we have to equally consider the mechanism for modeling and for not modeling but monitoring, like which panel is not contributing enough because of maybe abnormal temperature, because of bird drop, because of the dusty conditions, maybe because of cracks. So we have to come up with the idea, and the idea that we propose in this paper that actually addresses each class is efficient net P naught model. Lastly, I would like to thank Interdisciplinary Research Center for Aviation and Space Exploration, for King Fahd University of Petroleum Kingdom of Saudi Arabia for their advanced research facilities, and the technique used in this research contribution has been developed through an internal project. We call it INAE 2408. This is the these are the references. These are the references for the paper. And thank you so much, ladies and gentlemen. If you want, I'm unable to travel over here because I got sudden emergency. Otherwise, I could have joined you and would have answered your queries in physical. But my co-author is there, and Dr. Amjad Ali Kumbo. And if I would like to request him if he can handle few questions. Other than that, if you can email me directly to mustafa.abro@ieee.org, I'll be happy to answer your queries. Thank you.